Hello everyone. Today we will discuss the concepts of light. Well, have you ever seen any object in the dark room? Well, obviously no. Why it is so? Because to see any object, we need a light. So, without light, it is just not possible to see any object. Right? So, let's start with the definition of light and how it makes things visible. Okay, just write down first the definition of your light. Just write down, okay, definition. So what is light actually? Definition. So what is light? Number one, it is a form of energy, right? It is what it is? It is a form of energy. Number one, form of energy that produces sensation of sight. Sensation of sight, right? So what it is a form of energy that helps us to see any object with our sense, that is eye. So this is the definition of your light. Now we will study how it makes things possible. Okay, just write down what makes things visible. Just write down here what makes things visible, right? So what makes things visible? Let's see. Eye alone not only help to see any object, right? So the light from the object enters into our eye, only then we can see object. Right? It means not only eye that is able to see object lonely. It is how do we see objects? That when the light fall on the object, after that light enters into our eye, only then it is possible to see the object. Otherwise it is not possible. So it is either transmitted or reflected by an object. Now what is reflection? These two terminologies have been written here, that objects can be either transmitted or reflected, or light can be transmitted or reflected by an object. Only then it is possible to see the things easily, or things visible, right? Now what is reflection? There is the term arise, reflection. So just look at here, just write down reflection. What is reflection of light? Reflection of light. Okay, when for example, okay, I'm giving you one example, that if you throw a ball on a wall, what happens? It just comes back, right? After touching the wall, it just throw back, bounce back. So this is how, when the light falls on any object, it bouncing back in the same medium. We have already studied in class 7th that what is medium, that helps the light to propagate, right? So if it is the same medium, that is, this phenomenon is known as reflection of light. So we can write it. What is reflection of light? It is the bouncing back of light. It is, just write down, it is the bouncing back of light in same medium. When medium is same and the light reflects back or comes back after striking at a surface, that is known as reflection of light. Okay, then after striking, what it happens, it just enters into our eye. After reflection, it just enters into our eye, and that makes things visible to us, to our sense organ, that is eye. So this is how that things are visible to us by the phenomenon of reflection of light. Okay, so okay, this is reflection of light. Now we have two laws as well, right? So we are going to study next laws of reflection. Okay, this is how reflection of light and what are the terminologies including in the reflection of light. Let's start with that only first, right? Just okay, in class in standard 7th we have studied that a mirror, right? It is a reflecting surface. It is a polished surface that reflects the light. So this is how we just draw the mirror and see how light have been reflected and what are the terminologies included in the reflection of light. So this is our mirror. Okay, just this is our mirror polished surface, right? Okay, this ray of light falls on an object, this is a polished surface, and bounce back in the same medium. So this one and going back, right? So this is another one. Okay, now this ray which falls on the object, that is called incident ray. Incident ray. And the ray that reflects back, that is called reflected ray. And this is called normal, right? And this is mirror. So this is how reflection takes place. That direction changes, but in the same medium, right? Okay, so another terminology is related to it, that the angle between the incident and that angle makes by the incident ray with the normal is called angle of incidence, and the reflected ray, the angle makes by reflected ray with the normal is called reflected ray. So these are some terminologies of reflection. This is how reflection takes place in the polished surface, right? Okay, now let's start with the laws of reflection. We have, just write down, laws of reflection. Laws of reflection. So basically we have two laws of reflection, right? Number one, just write down angle of incidence. Okay, number one, we can write it that angle of incidence is always equals to angle of reflection. This is here. Okay, angle of incidence, that is angle I, is always equals to angle R. That is one of the law of reflection of light. Number two, that incident ray, just write down incident ray, reflected ray, and normal all lie on the same plane, right? All lie on the same plane means this is the incident ray, this is the reflected ray, and this is the normal. Look, this is one of the plane, right? This is the two-dimensional plane. So all the rays lie on the same plane. So this is the another law of reflection of light. So these two are the laws of reflection of light. And another one is another concept is, okay, when normal, this is the normal ray. The question is when, okay, this is 90 degree, we know that. Okay, the question is when the ray of light retraces, normal is always, this is just write down here, note that normal always retraces its path. Why? Because look at here, incident ray falls at some angle, only then it reflects back at some angle, but normal does not fall at any angle. It falls normally actually. Normal matlab makes 90 degree with the mirror. So it just retraces, it reflects back at the same way, at the same path. So that is why the normal always retraces its path. Now, why normal always retraces its path? This question arises. Okay, so we know that how normal, just look at again the normal with the plane mirror. This is a plane mirror, right? Normal is just like this. This is normal, right? Perpendicular. So the question is normal always retraces its path. Why? Okay, so question is, so answer is that because the angle of incidence, angle I and angle R is always equal, we know that, but how much it is? It is 0 degree. Just look, this is the angle incident ray with the normal, right? Incident ray, we know that angle I is what? Incident ray. So what is incident ray? The ray makes with the normal, right? Strikes on the plane mirror. So this is the incident ray. The angle made by the incident ray with the normal, that is 0 degree. So reflection always also 0 degree. So this is why the reason is normal always retraces its path. Okay, so this is the concept of laws of reflection. Now we have two types of reflection we will study about. Just write it down. What are the two types of reflection? That is reflection types, right? That is number one, regular, number two, diffused. Regular reflection and diffuse reflection, or we can call irregular reflection. So what is the difference between these two? We'll study about. So when parallel rays of light after striking on the surface, just look at here, when parallel rays of light, these are the parallel rays, strike first, let me draw it first. This is the mirror. Okay, when the parallel rays of light after striking on the surface are parallel, they reflect back parallelly, right? This is how. Then this type of reflection is called regular reflection. Okay, but when the rays of light after striking on the surface, they reflect back irregularly, this is known as diffused reflection. Okay, let's make some examples. Let's study about some examples of these two, regular and diffuse reflections. Well, when you are reading a newspaper, any book, any notebook, or you see any object lying anywhere in your at your home or in your room. So how could we see that? We all know that it is just due to the reflection. But what kind of reflection it is? Those rays of light, they are diffused, they are irregularly spreading over the area. This is the reason only we can able to see the whole area at once. Okay, so these are the examples of diffuse reflection. That we are reading a newspaper, we are reading a book, we can able to see all the words or all the sentences of that particular page. Okay, so it means it is just due to the diffuse reflection because light is spreading all over that book, all over that page. But if it is in the case of regular reflection, what it happens then, have you ever observed at a rainy day, when your headlight of a car falls on that smooth surface, watery surface, what happens? It just glare to your eyes, right? So this is a regular reflection that it focus on a particular area, a single area, not area around it. So that is called the regular. That is the best example of a regular reflection. So these are the difference between the regular and the diffuse reflection, right? So next, when you stand in front of a mirror, what do you see? Of course, you see your face, right? So, what is that face called? The picture of your face at that time is known as image. So, we can define image. The picture of any object in the mirror you see, that is known as image. Object is you, but your face, your another image, your another face in the mirror you can see, that is known as image. So we have two types of images. Just write down first what it is. It is image, right? So image is what? Image is what? The picture of any object in the mirror. Object in the mirror, right? So this is called image. So we have two types of image: real image and virtual image. So what is the difference between real and virtual image? Well, real image, when the beam of light after reflection meet at a point. So this is known as real image, when actually they appears to be meet, right? But virtual is when they do not actually meet at a point but appears to be meet. Okay, they are not actually meeting at a point, at some point, but what we do, we diverge it and try to be meet at some point and make an image, right? So that is called virtual image. That is not real image. So example, I'm giving you example that will help you more to understand this concept, right? So real image is what? When you use your cameras for photography, right? Projectors, right? And cinema screens where you see the cinema, where you see the movies, right? So these are the real examples of your real image. And virtual image, when you see your face in the mirror, this is the best example of virtual image, right? So these are the real life examples which might be helpful, or which will actually helpful for you to understand these concepts. So real image, now we will study more about real and virtual image. So real image can be obtained on a screen. Okay, when you take a screen in front of rays of light, that is actually we can see that image actually on the screen. But in case of virtual image, we cannot actually see. That image cannot actually appears, but we only just draw it, diverge it, and meet at a point. Okay, so this is called virtual. Now we will discuss the difference between these two. So first we have discussed that real image is image when rays of light after reflection meet at a point. So in virtual, it does not meet at a point. Actually, but it appears to be meet at a point. This is one of the difference. Another difference is we have already studied as well that real image can be obtained on a screen, but virtual image cannot be obtained on a screen. Right? One more difference between is real image is always inverted. Just write it down. The word is inverted. I have used inverted. Right, just write it down. Inverted. And here it is. Virtual image is upright, or we can write it as erect. It is always erect. Okay, so these are the two terminologies, inverted or erect. How it could be, if the object is like this is object, for example, inverted means your image would be like this. Okay, but if it is in case of virtual, if your object is like this, your image will also be like this. So this is erect, upright, right? So this is invert to your actual object, right? Okay, I will tell you where you can see the inverted image, because you can easily see erect image when you are, stand in front of a mirror. But I can tell you where you can see inverted image. So take your spoon, take a spoon. This is inner side of the spoon. Just look at here. This is the inner side of the spoon, right? And this is the outer curved. When you look at the inner side of your spoon, you can see your inverted image. Your image is downwards. Your face is downward and the lower part is upward. So this is the best example where you can see the inverted image. And in the outward corner, outward part of the spoon, you can see the erect image of yours. So this is the real life example where you can see, and you can try once. Okay, next we have mirrors. We are going to discuss a little bit about mirrors, where the reflection takes place actually, right? So okay, basically we have two types of mirrors. Just write it down here. Mirrors. Okay, we have basically two types of mirrors. What they are: plane mirror and spherical mirror. Okay, inside the spherical, further we have concave mirror and convex mirror. So this is the example of concave and convex is in the spoon as well, right? So this is inward part of the spoon acts as a concave mirror, and outward part of the spoon is acts as convex mirror. So you can easily find out that in concave mirror, what kind of mirror what kind of image it made, that is inverted. And in case of convex mirror, what kind of image have been formed, that is erect. Okay, so let's talk about some properties of plane mirror. So what is plane mirror? That is actually you are actually using inside your home. Okay, just you tell me what are the properties of plane mirror one by one, right? Because you have already used, okay, and you use it regularly, especially girls, not only girls, but boys as well, right? Okay, number one, what kind of image it is formed, inverted or erect? Erect means what you look like, similar is the way your image looks like. So obviously this is not erect, that is it is not inverted, it is erect. So we can write image formed by plane mirror is erect. Okay, number two, can write down. Okay, next is the size. Okay, what kind of size of the image will be that is same. So we can write size of object is equals to size of image, or size of image actually is equals to size of object, which you can write here, or virtual as well, right? Virtual or erect. Number 3, the distance of the object behind distance of the object is equals to distance of the image. Okay, so you can write distance of image behind the mirror equals to distance of object in front of mirrors. Okay, one more property of plane mirror. Just tell me what is left with. Okay, have you ever observed, if not you can try, okay, when you lift your right hand, how it looks like in the mirror? Amazing, it looks like right hand of your body. So if you raise the right hand of your body, it can appears to be left hand. So it is just vice versa. So that phenomena, that property of the plane mirror is known as lateral inversion. So write it down. Lateral inversion. This is a very important property of plane mirror. This only holds by the plane mirrors, not only any other spherical mirrors, right? So these are some properties of the plane mirror. Let's study about some properties of spherical mirrors, that is concave. So concave mirror is, just look at here. Okay, I can show you, I have shown you the spoon, right? So inner side of the spoon acts as a concave mirror. So just draw it like this. Concave mirror is this one. Okay, this is polished surface and inside is reflecting surface. And we know that what kind of image it formed? That is real or inverted. Okay, next is convex. This is concave. Next is convex. Outward part of that spoon is, convex mirror. So this is polished surface, and this is outside reflecting surface. This is convex. And what kind of image it formed? Virtual and erect, right? So these are spherical mirrors. Okay, so next is, okay, now you have observed, most of the time we have visited a shop, barber shop, and take a haircut. So when they have finished their haircut, they have, given us another mirror despite of in front of us, by looking at our hairs, if it is good or not, right? That is, they lie just behind us, so that we can write our we can see our hairs, look at hairs properly. So this is what, that is the concept of multiple images, right? How multiple images be formed? When 2 or 3 plane mirrors, they are recombined at some angle. When they are recombined with some angle, there are so many images formed. There are number of images formed. Okay, you have also observed number of images in some, some over some screen, in some saloon sometimes, where there are a lot of mirrors, and you can look your multiple images at a time. So this is what that is multiple images. So how could it be formed? The formula, how could number of images be formed? That is, the formula for number of images is small n is equals to 360 degree divided by theta minus 1. This is the how number of images formed. Theta is angle of recombination of plane mirrors. Okay, this is n is number of images formed. Number of images formed. And this concept will again try to find out and try to explain the concept of kaleidoscope. Kaleidoscope, in which we have seen various colors or different colors of any object.